there, in today's lesson we are going to learn differentiation of trigonometric functions. So before we move for differentiation, let's go over the formulas once again, which you have done in year 1 and year 2. So I'm just going over the formulas which we will use in today's lesson. So we know that d over dx of sine x is cos x. Okay, now d over dx of cos x is minus sin x. I'm just explaining you all the formula. And d over dx of tan x is sec square x. Okay, now what happens if k comes here, like sin kx, differentiation of sin, here is k, you can see here is kx. So what will happen? So it is by substitution, if you assume kx as a u, so k will come forward, so this k will come forward here, and differentiation of sine x is cos x, so it is kx, so we can write down here k cos kx, right? Similarly here, if it is d over dx of cos kx, so this constant comes forward, and cos kx differentiation is minus sin kx, so we put minus sign and it will be sin kx. Okay, now if it is differentiation of tan kx, so no need to say, any constant is coming forward, and differentiation of tan x, you can write down sec square kx. Okay, now we are going to learn some more trigonometric functions here, like d over dx of sec x. Okay, so I'm just writing you formula, then I will show you how we can get it. So d by dx of sec x is sec x into tan x, right? So what happens if k comes here? If k comes here, like d over dx of sec kx, as I told you, k will come forward here, and differentiation of sec x is sec x into tan x, so you can write down here sec kx times tan kx. Okay, now next one is d over dx of cosec x. Cosec x, d over dx of cosec x is minus cosec x into cot x. So similarly here, if it is cosec kx, so I'm telling you again and again, so k is coming forward, and cosec kx is minus k cosec x into cot x, so we put here minus sign, and cosec kx times cot kx. And the last one is cot x, differentiation of cot x. Differentiation of cot x is minus cosec square x. So if k comes here, any constant like cot kx, so it will be minus k cosec square kx. I can explain you one thing, how things are happening. Yeah, let's take this example cot x here, and this example d over dx of cot kx. Let's take k as a 4. Then what will happen? Yeah, so let's see. I'm going to explain you this example. I'm assuming k as a 4. So what will be differentiation? So if it is d over dx of cot 4x, yeah, so here k is 4. So what will happen? So see, so we know dy dx of cot x is minus cosec square x. So I'm explaining you detailed explanation how it is happening. So if y is cot 4x, okay, and we need to differentiate with respect to x, so d over dx of cot 4x, yeah. Now 4x we can suppose as a u. So if we suppose for x as a u, then it will be cot u. Now it is u and it is x, so we can use chain rule. So it will be d over du, multiply by du here, cot u, and multiply by du in the numerator, and this dx is already in the denominator. So d by du of cot u, so d by dx of cot x is minus cosec square x, so d over du of cot u is minus cosec square u. What is du over dx? So if you differentiate, Differentiation of 4x with respect to x, it is 4, and it is du over dx. So it is 4. So you can see 4 is coming forward and put the value of u back. So minus 4 cosec square, and u is 4x. So see here, if it was kx minus k cosec square x, if it is 4x, then it will be minus 4 cosec square 4x. So here we can write down directly minus 4 cosec square 4x. Okay, let's go for another question. Example 2. Like let's take d over dx of cosec 4x. Yeah, so we need to see what is d over dx of cosec x. So d over dx of cosec x is minus cosec x into cot x, right? Minus cosec x into cot x. So this 4 is coming forward, this 4 is coming forward, and minus sign cosec x into cot x. So here it is 4x cosec 4x into cot 4x, right? You can write down in one line if you know the formula, otherwise you need to apply chain rule and go for detailed method. Let's take another example. Example 3. Suppose y is cosec 3 2x. Okay, here is cosec cube 2x. So same thing, we can do it here. Let cosec 2x as a u, so it will be dy by dx. So if we have suppose as a u, so by applying chain rule, it will be u3 and du over dx. So dy dx of cosec 2x will be, okay, cosec 2x, it will be minus cosec 2x into cot 2x, and this 2 comes forward, so write down here. So this is du over dx. Now d over du of u3 will be 3u square, and du over dx is this value. So let's write down here minus 2 cosec 2x into cot 2x. Put the value of u back, so it is 3. U is cosec square 2x. This minus 2, if you multiply, then it will be minus 6. So let's cancel it here and write down here minus 6. Okay, I can rub it, it will look little bit good. Yeah, so minus 6. Okay, so it is minus 6 cosec cube 2x and this cot 2x. Okay, nice. So let's move forward. Another question, example 4. If y is cot square 2x minus 1, so what will be the differentiation? So please pause the video and have a go. Welcome back if you have tried. So here what we are going to suppose u, so cot 2x minus 1 as a u. So it will be dy over dx, so it will be d over du u square and du over dx. We are applying chain rule here, because if you are putting u's, then it should be u here and u here. Okay, cot 2x minus 1, if you differentiate, so it will be minus 2 cosec square 2x minus 1. This 2 is coming forward and it is du over dx. So this du over dx you are going to put here, and d over du of u square is 2u. So 2u, and this minus sign minus 2 cosec square 2x minus 1 and bracket closed. Let's change the bracket. Okay, now if you multiply minus 2 and 2, it will be minus 4. Okay, and u is cot 2x minus 1, so cot 2x minus 1, and this is cosec square 2x minus 1. So this is your answer. Okay, I hope you are developing understanding how we are applying chain rule here. Okay, now next question. So next example is if d over dx of root cot x. Yeah, okay, root cot x. Suppose question is like this, y equal to root cot x, then what will be the differentiation? So again you assume cot x equal to u. Okay, so this will be d over dx of u to the power half. Now this is u and this is x, so we can apply chain rule. So times by du here, u half, and du over dx. Okay, u half will be 1 over 2 u, 1 by 2 minus 1, that is minus half, and du over dx we can find out from here. So it will be cosec square x du over dx. So it will be cosec square x. So your final answer will be half. U is cot x, so it will be cot x to the power minus half. Okay, and if you want, you can put it in a bracket, and it is cosec square x. Okay, that is your final answer. Let's go for another question. So here y is tan 2x over x. Okay, so here you can apply quotient rule. So this is u and this is v. If you want, you can apply product rule as well. In that case, then you can write down like this. So then this will be u and this will be v. Here you can apply product rule, and here you can apply quotient rule. So let's apply quotient rule here. So u is tan 2x. So u dash will be differentiation of tan 2x. So this 2 is coming forward, and tan x is sec square x. So it will be sec square 2x. Okay. Now the next one is v. V is x. V dash will be 1. So first you need to multiply this like v u dash minus u v dash over v square. This is quotient rule. Okay, so it will be 2x sec square 2x. Then you multiply this with minus sign, minus tan 2x times 1, that is tan 2x over x square. So this is your answer, right? Similarly, there is another question we take. So example, if y equal to e to the power x sec 3x. Okay, so here you can apply product rule here, and if you don't want to apply product rule, you can change this question and in this form cos 3x, because sec x is 1 upon cos x. If it is 3x, sec 3x will be cos 3x. Okay, so if you are using this, then you can use quotient rule, and if you are using this, then you can use product rule. Okay, so I'm going to use this. So here u is e to the power x, u dash differentiation of ex will be e to the power x, v is sec 3x, so v dash will be, this 3 is coming forward, and d over dx of sec x is sec x into tan x, so it will be sec 3x into tan 3x. Okay, so uv dash plus vu dash, yes, so we can multiply this. Your product rule is uv dash plus vu dash. So dy over dx is, I'm multiplying this, so 3ex sec 3x into tan 3x plus e to the power x sec 3x. Okay, now if you see here e to the power x sec 3x, here also e to the power x sec 3x, so let's take it out, e to the power x sec 3x. So we are left with 3 tan 3x plus 1. That's your answer. And our last example is if y equal to 1 over cos x and sin x. Okay, so here also we can apply quotient rule. So u is 1, u dash is 0, v is cos x, sin x v dash. So here you need to apply product rule again. So like product rule. So cos x, differentiation of sin x is cos x, then plus sin x, okay, and differentiate plus sin x, differentiation of cos x is minus sin x. Yeah, so here we are applying again product rule. Yeah, so for quotient rule we multiply this first. So like v u dash minus u v dash divided by v square. So if you multiply cos x sin x times 0, so this will be 0, then minus u is 1, v dash is cos square x, and this plus and minus becomes minus sin square x over v square, and v is cos square x and sin square x. Okay, so if you multiply by this minus sign, so we can change it, so it will be minus cos square x plus sin square x. So let's write down here minus sin square x minus cos square x over cos square x and sin square x. Okay, so this can be your answer, or we can simplify a little bit more. So we know this, like if 3 minus 2 over 5, then we can write down 3 over 5 minus 2 over 5. So here we can write down, let me change different ink. So this upon this, like sin square x over cos square x times sin square x minus cos square x over cos square x times sin square x, right? So let's cancel out. So here sin square x cancel, cos square x cancel. So we got 1 over cos square x. 1 over cos square x is sec square x. 1 over sin square x is cosec square x. This is your answer. So I hope you have understood differentiation of different trigonometric functions, and these formulas are really important. So I have put all these formulas for you here. You can go over it again and again, and it is going to help you. So in my next video I'm going to do next level of differentiation. Till then, goodbye and thanks for watching. And if you haven't subscribed my channel, please subscribe my channel. Thank you once again. Bye bye.